Hello and welcome to Vase Projects. Today I'm going to be going over the dynamic position analysis of the ButterBot. Now I know that probably sounds like the most boring thing I could have said, but don't worry, down the line there's going to be plenty more boring things to listen to, so just have to wait and see. Now, I know a lot of people hate math, and the only thing worse than doing math is watching someone else do math. So when I do this, I'm going to try to do it in a way that doesn't fill you with rage and hate against me. Let's go to the board. Dynamic position analysis, the mayonnaise of dynamics. Let's start with the really basic arm outline. We have a joint, an arm, and an arm. Alright? Here we're going to have the knife. We're not worried about that right now. We're just doing position. Real basic position. Here we would have a base, but we're not worried about that right now. We're just doing the real basic position. Real basic. This is link 1. We're going to call it L1. Try to figure out where that came from. This is L2 for link 2. Alright? The ground point, we're going to call that N. Why is ground N, you ask? I don't actually know. This point we're going to call A. And this point we're going to call B, because A is before B in the alphabet, and this point is before this point in the linkage. With how we need to do this generally, we have this thing called moving frames. This is where you start to hate me. You have two things going like this, but this moves in reference to, the ground here. If this is fixed, that moves in reference to this piece. So this piece has a frame different than this piece, which is what we have going on here. So we need a ground frame. Y and X, and that's N. This is very important. It's the ground frame. Then we have an A frame. I'm going to draw that here from the center of mass. X will be here because it's easier that way, and then this will be Y. And then finally, for the B link, X and then Y. You with me so far? Since this frame rotates in reference to here, this frame will rotate in reference to this link. Alright, now we have to talk about angles of rotation. If you start to hate me, put the timestamp of when you really hate me, put that down below, and I'll remember that and laugh at myself. This is, when you have something laying on the ground, it is 0 degrees removed from the ground. When you have something up from the ground like this, this is 90 degrees from the ground. Fair enough? This angle, we'll call it theta 1, is the rotation of x hat A from xn. And then we're going to have this angle, theta 2, that's a really bad theta, which is the rotation from A to B. And now we have to model the rotation. This is where the math comes in. Oh yeah, you thought we got to the boring part. We're still getting there. Alright. We draw frames. This is xn, this is yn. This is XA. This is YA. This is theta 1. This is theta 1. How we model the rotation is something I'm going to use. For those of you who do know dynamics, I'm going to be using the rotation matrix. For those of you who haven't looked at trigonometry since high school, Don't worry about what it's called. I'm going to write it out for you. Just remember that it's sine and not sin. We're going to have XA is equal to cosine theta 1 xn minus sine theta 1 yn. And conversely, ya is equal to sine theta 1 xn plus cosine theta 1 yn. We would do this the same for.
What will we do it the same for? Is he writing on the board with sidewalk chalk? Will he have any subscribers left after this video? Find out next week on Vay's Projects, the ButterBot.